Okay, so if you didn't already pick up your assignment, you can get that after class. The grader did a quick turnaround over the weekend. And as usual, I'll say that if the grader has made a mistake in scoring your assignment, please let me know. You can bring your assignment to my office hours, and I'm happy to take another look at it. I want to make sure that you get all the points that you deserve. We have an exam coming up on Wednesday. And so I think that should be the top thing on your to-do list over the next couple of days is review the material that we've had since the first midterm exam. The exam 2 is just going to cover since the first exam, and you should definitely bring a computer to class on Wednesday because I'm not going to have any of those. You know, if you don't have a computer, you can check one out from the library. But one of the questions is going to be related to an Excel problem. And so one of the things you maybe should consider doing over the next couple of days is review the spreadsheets that you've done so far since exam 2 and just see that you understand sort of what's the objective of each of those spreadsheets. And I'll remind you again, I mentioned this in the last class, but when you solve a spreadsheet, you'll have the answer somewhere on the page, but you need to also make sure that on the exam paper itself, you write, what's the conclusion or what's the interpretation of the results. And so just calculating the numbers is only part of the problem, and you have to be sure that you can understand how to apply the decision criteria and answer the question, for example, which alternative is best. So just as an extra warning about that. All right, so your next assignment's not due until a week from today. Homework 11, that's having to do with replacement, retention, and budget limits. So we did the first thing last class where we were talking about replacement decisions. Today we're going to do a comparison between alternatives, which is just kind of an extension of the same economic service life decision that you've seen so far. And then after the exam, we're going to start talking a little bit about budget limits. And then, of course, just a reminder that the project is hanging over your head. And if you have any questions about the project, please feel free to stop by my office because I'm anxious to move you along on that process as much as possible. All right, so today we're going to be talking about replacement studies. And here you can see two very different electronic control panels for a chemical plant. And I guess maybe even to call the one on the left an electronic control panel is maybe a little bit of a stretch. It looks like something straight out of the 50s or 60s. But in many cases, technology doesn't improve on what the old stuff was doing. It just maybe makes the display a little bit more attractive. And so when you're doing comparisons between alternatives, you have to distinguish between the alternatives that are just a direct substitute for the old item, and those which are somehow enhancing productivity or allowing you to create a product that wasn't created before. In our analyses today, we're going to be looking only at things that are considered a direct substitute. And so what we'll really be doing is comparing costs and trying to identify which of these two items has the lowest cost, because our built-in assumption is that the items are interchangeable in terms of what they produce and how efficiently they can be used. So our objective in these comparisons is to minimize the cost and find whatever's the least expensive way to do the business. We're going to have our existing item be known as the defender, and then the new alternative that we're considering is the challenger. And that sounds kind of like gladiators or some sort of American Ninja Warrior, but unfortunately it's not quite that exciting. It's a spreadsheet comparison. So we're going to have a defender and a challenger, and we assume that the whole reason that we're already considering them is that they both meet the required specifications, that they're good enough, and someone before us has screened out any alternative that doesn't meet the criteria. So you don't have to consider this in terms of a reject one of the alternatives. Both of the alternatives are okay, but one of them is going to have lower costs than the other. Now, there's two different situations, one where we have to do this analysis with no study period specified in the problem statement. And then in some cases there will be a study period specified, and that has to do often with the life of the equipment. So we'll look at the first alternative where there's no study period specified. Now, what you're going to do is economic service life analysis for both alternatives in the same way that we did on Friday in class, where you're going to take any costs that exist as a first cost and spread it out over an annual worth. You're taking the market value and spreading that out over an annual worth, and you're combining those two things with whatever operation and maintenance costs exist on an annual basis. So we do that for both the Defender and the Challenger, and then you select the one that has the total lowest cost between all of them. Now, what you're going to be doing is projecting some values into the future. You're going to be assuming that, for instance, the market value that you're predicting today may be declining at some rate over time. And often these alternative comparisons can be done over 7 or 8 years. So although you'll pick which alternative is best today, I have to make the point that you need to revisit the decision, and it's common to revisit it on an annual basis just to see if maybe changes in the market life or maybe changes in the operational costs have changed things. So for instance, whatever you choose, maybe you select the Defender. Like it's cheaper to keep the existing equipment is what you decide right now. A year from now, you have to come back and say, is that still the case? Maybe there is a special on the price of the Challenger. Or maybe the Defender broke down earlier than expected. Or maybe its market value is less than anticipated. And so the facts may change, the facts that underline your analysis. And one of the nice things about having it in a spreadsheet is you can easily update the analysis with the updated market values, the updated operational costs, maybe interest rates have shifted. And so if you already have the analysis from last year, it makes it fairly straightforward to adjust it and find out which alternative is best. Okay, so here I have a in-class exercise where you're going to be starting with a template file that once again I've put on to MU Online. So you can go to MU Online and download that Excel file. It's in the content area at the bottom of the list. And you're comparing two alternatives. It's robot systems and the Defender is the equipment that you own right now, and it's only going to last for 3 years. And so you're going to have to compare that to a Challenger that's going to last 6 years, but of course it's more expensive. Now, I mentioned this last class period, and I want to emphasize it again, that there's an opportunity cost associated with keeping the existing equipment. Does anybody remember what is that opportunity cost? If you decide to just keep using the equipment you already own, what are you giving up by doing that? The current market value. That's exactly right. So the point is, when you're comparing these two alternatives, it's not that the Defender is free. Actually, you have to pay money, in a way, to keep the Defender when comparing it to the Challenger. And the money that you pay of the Defender is whatever you could have got for it if you sold it on the open market. And so that would be sort of an artificial comparison if you said that the Defender had no value now. It would always make the Defender look a little bit more attractive than it actually is. So in that spreadsheet file that you can find online, if you go and download the template and open that in Excel, you can start filling in the data from the problem statement. The problem statement is telling you about the interest rate, the market value of the existing equipment. It says is $15,000. And it declines by 20% each year for 3 years. And so, just because I've known this to be a point of confusion in the past, if the first cost right now, we're going to put down the market value of the existing equipment. So if we say negative 15,000 for our existing, what should be the market value at the end of the first year? How can we find that 20% reduction? Any ideas about that? Well, the easiest way is just to say it's 80% of the value from the year before. So 20% reduction means it keeps 80% of the value. So what you can say for the market value at the end of the first year, it's equals 0.8 times this first cost. And then the next market value would be equals 0.8 of whatever it was the year before that. Somehow it looks like, okay, times the previous year, and so on. Okay, so with that, I'm going to pause the recording, stop talking, and give you some time to start filling in each of these columns. It's the same idea as the last class. You'll notice that I just have one column for capital recovery. You can calculate that either of the two methods that I showed in class last time. The easiest maybe is to do the payment function with both the market value and the first cost. But I'll leave that up to you, and then we're going to take a look at answering this question at the bottom here. What should the company do? Should they keep the Defender, which is the existing robot equipment, or should they instead sell the Defender and buy the Challenger? And the answer isn't just buy the Defender or keep the Challenger, or vice versa. You also have to say how many years they should own it. So it's kind of like a two-part question, and the criteria is whatever has the lowest annual worth of cost, that's the equipment you go for, and that's how long you keep it. Okay, so here G is E plus F. There is no column I. All right, guys, one more correction. The first cost is negative because, you know, if you don't sell the item, effectively you're having to give up that $15,000. But now here in market value, whichever year you go for, it's assuming that you do sell the item. And so it should be actually $12,000 would be a revenue, and so it shouldn't be negative. It should be positive for that first one. And so these amounts should be positive values because it's revenue rather than costs. It's only cost at year 0 if you assume that you didn't sell the item. So sorry for that. I didn't point that out when I was showing you what to do for these market values. But the market values should be positive, whereas the first cost is negative. Let me show you guys an interesting little shortcut, something that'll maybe save you a couple of keystrokes over your lifetime. You know, each cell has a name based on its column and row reference. So for example, where the interest rate is B4, right? You can also give it a secondary name over here in this cell. So we could call it, for example, interest rate, or int, int. So see how I've labeled that int? So now here, any place in the formula, if I want to refer to that location, I don't have to type in B4 or move the cursor over there. If I'm doing the NPV function, I could just say equals NPV and the rate. I just type in int, and then it knows I mean that location. So it's kind of useful. You could even just label it, I think, with a letter, although I'm not 100% sure about that. You can definitely use int, because I just did. So that might save you a little time. Okay, someone just asked the proverbial question, will this be on the exam? And the answer is that I won't give you any problem-solving questions related to this on the exam, and so you won't have a spreadsheet problem, but I could ask you a conceptual question on the exam from it. But you will need to know this stuff for the upcoming homework assignment, and so I'd encourage you to save the spreadsheet file that you're working on right now so that you can come back to it as you're working on the homework that's due a week from today. All right, let's just talk about the interpretation of this and then move on to the next comparison of alternatives. Basically, when we go through and compare these two options, it seems that the cheapest thing overall the best alternative is to keep the Defender for 3 years and then sell it at the end of 3 years. That's the one that gives us the cheapest. The least expensive alternative with the Challenger ends up costing $19,123, but we can beat that by keeping the Defender for 3 years. So the question is, what should we do after those 3 years? Well, in a situation like this where the study period isn't specified, you kind of just ignore what happens after this. The assumption sort of is that repeatability applies, and so you could repeat the alternatives and have an ongoing cost that's same as that, or just you reconsider the situation after 3 years, because right now these are the two options that you're facing. Buy something new or keep the old equipment. And so far, the buying something new option isn't justified because there's more useful life available in the existing equipment based on the economic analysis. Okay, so if you haven't yet got this, that's okay. You can save your work, and if you need to come back to the video, you can watch in slow motion as I go through each of these. By the way, YouTube lets you change the speed as you're watching a video. So if you want to speed through the lectures, you know, to cram for the test, you could turn like up to 5 times speed, and I could talk really fast, and you'd really get a lot of information in quickly that way. All right, so let's look at this next question, where what we're going to do is a replacement study where the study period is specified. So we have to consider over a certain number of years which alternative is best. This last one that we just did, one of the alternatives was 3 years, the other was 8, but it was okay, no, 6, but it was okay. We were just, we're fine with the fact that they were different useful lives because we were going to reconsider what to do after the existing equipment wears out. But if you do have a study period specified, oftentimes what it is the useful life of the Challenger. And so you're saying we have this new equipment that's going to last for a certain amount of time, and we want to consider if we buy that, is that better, or is it better to keep the existing equipment and then maybe do something like leasing through contract services? Or should we purchase this Challenger later on down the road instead of buying it today? Now, the example that I'm going to show you for this comparison of when the two alternatives have a study period specified, it's a little bit complicated, and I don't think we could solve it in the few minutes that we've got remaining. And so I'm just going to go straight to the solution for it after I explain what's happening. Okay, so we've got two alternatives. And this happens to be, I think, like aircraft navigation equipment is what's said in the setup of the problem. The Defender, our existing system, if we sold it right now, we could get $70,000 for it. And to operate it over the next 3 years has an annual operating cost of $30,000. Okay, the new equipment, the Challenger, if we buy it today, it's $750,000. And then it's going to last for 10 years, each of which costs $50,000. So what we do for comparisons like this is we want to find the annual worth, or the equivalent annual cost when you spread out the capital recovery and the annual operating costs. But we need to do it over the same number of years, and right now the Defender is only over 3 years. And so the idea here is that we're going to buy something else after the Defender wears out. Maybe it's the same equipment as the Challenger, but we're not going to have $750,000 as the price in the future because there's cost inflation. So we're going to have to actually pay more for the same item at the end of 3 years. And that's what the second half of this cash flow diagram is representing. First of all, we've got some new annual operating costs. So the $50,000 is the same amount as the Challenger was. The operating costs are the same over those future years. But these additional lines here showing the capital recovery is showing the annual equivalent of if we bought that item and then we spread it out over 10 years. Now, this is an example that comes from your book, and if you want to look at it in detail, it explains that you can move the equipment into another project after using it for a certain number of years. And so you see these dashed lines here. The interpretation of that is that when you buy the item for $900,000, then you need to spread it out over 10 years of life, but only 7 of those 10 years of life go into your project, and after that, some other group in the company is going to be using the equipment, and so they're the ones who are responsible for the capital recovery in those later years. So your group of the company, your division, would only have to be responsible for the first 7 years of capital recovery. So it's a pretty complicated cash flow diagram. Let me show you how I broke it up. This is actually a table lookup problem. That's why on the back side of the handout we've got the 10% table. The Challenger is kind of obvious what we have to do there. The Challenger, there's only one thing that we have to move to an annual cost, and that's the initial purchase price of $750,000. So what I did is I did an A/P, it's finding the annual value of that present amount, and combining that annual value with the annual operating costs of $50,000, and we find that the Challenger has an annual worth of a cost of $172,000 approximately. Now, the Defender cash flow diagram is more complicated. We want to take all of these different pieces, the 4 components shown here, the $70,000, which is the market value of the item that we're keeping. So we have to consider that. If we're keeping our existing equipment, we're giving up the opportunity to sell it. So that's why we have that $70,000 at year 0. Then the operating costs for 3 years, that's the next piece. And then the operating costs of 7 years of the new equipment. And then we have to account for those 7 years of capital recovery. Now, once we find these amounts, we have to spread it out so that it's one equal amount during each of the 10 years of the study period. So it's really a mess. We don't have time to go through the calculations necessarily, but I just wanted to point out what is the procedure when you have the study period specified. Basically, you have to do whatever it takes to make it the same number of years, whether it's using the repeatability assumption or if it's using contract services or early termination. Make it the same number of years and then find the annual worth. And if you do happen to solve this one later on, just because you are so anxious to find out which alternative is best, the Defender is best. And so you can go through the calculations. They're in the video. Just a reminder, be on time on Wednesday. Have your computer booted up or in standby so you can get to it relatively quickly. And I'll have some handouts for you, the equation sheet and the table lookup factors. So have a good one. Let me know if you've got any questions as you're studying, and I'll see you on Wednesday.